The first thing we did is just addition, subtraction, multiplication, and division of functions. So they're going to be set up just like this. It's going to give you two functions, and it's going to tell you to do something with the two functions, all right? I chose just one of each type. Addition, subtraction is basically the same, and subtraction is actually the more difficult of those. So I chose that one, and then a division, and then a multiplication, all right? So when it gives you something like this, you're literally just going to set up the two functions. This wants you to say G minus F. Pay attention to the order. It's not always in the top one minus the bottom one, so pay attention to that. You have the G function, which is n squared plus 4, minus the F function, which is n plus 1. Number one problem here is negatives. That negative goes to everything in the second group. So I'm going to distribute that negative through to everything in the second group. So I have n squared plus 4, and that's minus n and minus 1, okay? And then you're just combining like terms. Nothing can combine with the n squared, so that's just going to be n squared. I have a minus n, and then I have a positive 4 and a negative 1, so I have a positive 3. And this is my answer. That's all I can do there. Subtraction is exactly the same, except you don't have to worry about a negative. You literally just combine like terms for addition versus subtraction. So subtraction, you have to worry about distributing your negative. Addition, you're literally just combining like terms, and you don't have to worry about that negative. Division. I am not going to make you do anything with domain on the quiz. I will on the test. We'll get into domain further. So in the quiz, you literally just have to tell me the answers. So for division, you're going to put the h function in the numerator, 3a minus 2. And the g function in the denominator, negative 2a squared minus 4. If I could reduce anything, I would. So if something came out of all of that, but I can't. So that's actually my answer. I'm done. For multiplication, a couple things I want to point out. First of all, the little dot means multiplication. The open circle means composition. So the dot means multiplication, which you're going to end up likely foiling when you have multiplication. Composition is the one we're about to do next, so don't confuse them, all right? For this one, you're just multiplying those two. Y'all have done this since Algebra 1, really. You're going to take the first function, a plus 3. You're going to multiply it by the second function, a squared minus 3. And then you're going to distribute a times a squared, that's a cubed. A times negative 3 is negative 3a. 3 times a squared is 3a squared. And then 3 times negative 3 is negative 9. I will say these really need to be in standard form. So what that means is you're going to do highest to lowest. Highest exponent, a cubed, to lowest exponent, 3a squared minus 3a minus 9. And that is your answer there. There are two ways it can ask you to do composition of functions. First, it can ask you just to leave it as a new function without a number, and the second way is to have actually plug a number in. So this number 11 here, you'll notice the notation. This is an open circle. This does not mean multiplication. This means composition. It means take this second function and plug that whole thing into the first function. So my first function here is f, which is t squared. So f of t is t squared, which means f of g means instead of t squared, I'm going to take this entire g and I'm going to plug it in for t. So I'm going to say 2 times t plus 5 squared. All right, I took the entire function of g and I plugged it into my t, into my f function, my t for my f function there. And then I need to simplify this. This just means 2t plus 5 multiplied by itself. So we're going to distribute first term, outer terms, inner, and last terms. And then we just need to simplify our like terms. I have 4t squared plus 20t plus 25. All right. So when it is a number, you do not have to create a new function. You can, but you don't have to. I chose this one specifically because people get confused when something composes on itself. But when it's a number, you literally just take the number and plug it into this function that's closest to the number. And then you take that answer from that and you plug it into the first function. All right? This happens to be the same one, so we're going to do it twice. But if it were two different functions, you would put the number into the function closest to it, and then put that answer into the first function that's there, all right? So for this one, they want g of 3. So we're going to take 3, and we're going to plug 3 into g. So we're going to say g of 3. Negative, instead of x, we're going to say 3 plus 5. Well, negative 3 plus 5 is just 2. All right? Then we're going to take that answer, and we're going to plug it into, in this case, the same function, because that's the first function. So we're going to say g of 2 now. That's going to be what we plug in. We're going to say negative 2 plus 5, and that gives us 3. It will not always be the answer you started with, so don't even think that composing on itself is going to be the same answer. The first thing we did is finding an inverse, okay? Finding an inverse. So your steps for finding an inverse, the first thing you do is you switch x and y. Remember, f of x or g of x, that is your y. So switch x and y. Then you're going to solve for y. And then make sure you change your notation to your f to the negative 1 or g to the negative 1 or whatever it was, whatever your function was. All right? So in this case, our first step is to switch x and y. Remember, this is y. So we're going to switch these two. Instead of y equals negative 2 plus x cubed, we're going to say x equals negative 2 plus y cubed. To solve for y, we need to get rid of everything that doesn't have a y. So we're going to move this 2 over with addition. We have x plus 2 equals y cubed. Y is still not by itself. It's to the third power. So to get rid of something to the third power, we take the root of that same index. So the cubed root then of both sides. All right, we now have our y by itself, and that's going to equal the cubed root of x plus 2. Because it's a cubed root, we don't have to do positive and negative. If it were an even root, like 2, 4, 6, 8, we would have to say positive or negative root here. But it's a cubed root, so we don't have to. All right? That is technically the inverse, but we need to correct our notation. Change this y back to function notation. So we're going to change that y to g of x, and specifically we need to put that negative 1 up there to indicate it is the inverse of it, equals cubed root of x plus 2. And that is our final answer right there. The reason I keep reiterating to put this notation here is this indicates it's your original function. You're actually telling me these are the same thing, and they're not. So that's why we need to correct our notation there, right? So that you are telling me this is the inverse function. This last section says, state if the given functions are inverses, use function composition to show why or why not. So when you are trying to figure out, are these inverses, you're not just going to look at it and flip a coin and say yes, no, right? Because I will count it wrong. You have to actually show me mathematically why they are or are not inverses. And so the way you show me that is you do composition between the two functions. It doesn't matter what order. It doesn't matter, for example, if you put f into g or g into f, whichever way is easier. But you have to do composition. You're looking for a final answer of just x. If they are inverses, then when you do the composition, your final answer will be x, and then they are inverses. If your answer is anything except x, they are not inverses. So let's just look at this first one. They want to know if G and F are inverses of each other. So I'm going to do the composition between those two. And I'm just going to go in order here. So I'm going to say G of F. It doesn't matter which order. I'm going to do that. So I'm going to take this whole function and I'm going to plug it in for the x value there. So G is 2 over, but instead of x, I'm going to write this big, huge guy here. Negative 2 over x minus 2 minus 2. That is my x minus 2. That's what I have there, x minus 2. And then don't forget I have a minus 2 out here. So that looks crazy, but it's not too bad. All right. Let's simplify it a little at a time. So this down here, I have minus 2 minus 2. So I have negative 2 over x minus 2 minus 4. I'm just simplifying my denominator for right now. So I'm simplifying this piece. When I do that, I have to get a common denominator here. So common denominator here is x minus 2. So I have something like that. So in my numerator position, I have 2 over, and I have this big guy here. Negative 2 minus 4x plus 8. That's what happens when I distribute over x minus 2. And I still have that guy there. Sometimes these actually work out. This guy doesn't. All right, combine these two. I have 2 over negative 4x plus 6 over x minus 2 minus 2. You can probably see this is not going to simplify to x, by the way, but the next one will. All right, for this piece, I'm going to keep change flip. We're doing a lot of math that we've already done before. So keep change flip is 2 times my reciprocal. Distribute here to x minus 4 over negative 4x plus 6 minus 2. All right. And if I simplify it all the way out, I'm still not going to get, if I take a 2 out, which is what I'm doing, this still isn't going to cancel. I'm going to get x minus 2 over negative 2x plus 3 minus 2. This is never going to simplify to x. Even if I get a common denominator here, it's not. All right. So this is my answer, and it does not equal x. So your final answer for this guy is actually going to be no. Question. So when you're doing these, you're going to take either way the function into the other one, simplify it out. Here I had plus minus, it canceled. Fifth root to the fifth, it canceled. Just x, yes, they are inverses of each other.